It is indeed. Thanks, Jake. AC. And we knew that by the reflexive property. Okay, so right now we have, I'm going to put two little lines there. We have one side. We have another side. So we're going to do this by side, side, side. SSS. What would we need to show? You have two sides. What else do you need to show for side, side, side?
The third side.
The third side. What's our third side?
AC.
AC, which is congruent to?
BC.
BC. Yep. Okay, if we were doing side, angle, side, we'd need, right now, we have side, side, side. We need the angle in the middle. What is the angle in the middle of these two sides? What are those angles? Sandwich right in between them. So side, angle, side, the angle is sandwiched between the congruent sides. What angle is between the two congruent sides? Lucas? We don't know for sure that it's right. So which one's between these two? Angle C. What angle is between this one? A. Now, unfortunately, there's more than one angle at those vertex, so we're going to have to label them with the 3 letters. So we'd have to use, which is congruent to CAB. Okay, and that would be this line here. I'm going to draw it in red. So that's that arc. And then we'd be able to use side, angle, side. For the next one, if we were going to do side, 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 what else would we need to know? Right now, you know one side and one angle. So for side, 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 we have to show the other two sides are congruent to two sides in the other triangle. So we'd need GH to be congruent to what?
KL.
Exactly right, KL. And we need to show, I'm not going to write another need. We need to show the other one, which is GF, which is congruent to JL. And that, remember, that is that hypotenuse. The one directly across from that right angle is the hypotenuse. So if we wanted to do side, 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 we had one side. We'd have to show the other two sides are congruent. If we wanted to show side, angle, side, right now, as it stands, we have a side and an angle. Remember that angle has to be sandwiched between the congruent sides. Side that's congruent, side that's congruent, angle. Which side is on the other side that sandwiches that angle? Say it again. Yep, GH. So we need to show GH is congruent to KL. I'm going to switch the slide. Is that okay? Our first question is triangle ABC congruent to triangle ADC by hypotenuse leg? So, does anybody want to tell me, can we do that? Can you use hypotenuse leg? So we had criteria for hypotenuse leg. First one, your hypotenuse has to be congruent to the hypotenuse in the other triangle. Is that met? I hear some and then some mm-ms. So, the key part of the hypotenuse leg theorem from the last slide is that it has to be a right triangle. You can't use it if it's not a right triangle. Is this a right triangle? No, so we cannot use it. So the answer to this is nope. No, we cannot. Not right triangle. Next up. So, does the diagram give you enough info to show that these triangles are congruent? And if so, by what theorem? So you look at this picture, and we see we have a congruent angle with B and D being congruent angles, and BAC being congruent to CAD. And we also have segment BC congruent to CD. Which theorem have we learned that would allow us to tell if this is congruent? Cam? SAS. That is a good suggestion. Can anybody tell us why that one may not make the most sense? Jake? Because there's two angles. So with SAS, you have two sides and one angle. And right now we have two angles and one side. Jake, do you want to finish it? So it's going to be AAS. How did you know that? Yep, so we have two congruent angles. We have one congruent side that is not included. So it's not in between those angles. Our next one over here, we see this picture. And we have angle F is congruent to angle H. We have segment GE is congruent to segment GE. And we have segment FG is congruent to EH. So based on that, which theorem, if any, allows us to? Serenity?
I got a question.
Yep.
That last thing you just said, you said, what's the, you said what?
So we see here, based on these tick marks, that GF is congruent to HE. I can highlight them for you, right here. These are the tick marks that tell us.
The ones in the middle, what those are?
That's telling you that GE is congruent to GE. The line is congruent to itself because it is in both triangles.
So the ones that's highlighted, that mean,
Those are just also congruent sides of the triangle. Okay, so does anybody have a solution for how they think we could show this? Yeah, Ethan?
These are SSA.
So Ethan came up with probably the only solution we'd be able to come up with, SSA. Unfortunately, that is not actually a congruence. So no, we would not be able to show it. So the answer is no, because the angle is not included. So again, for us to use side, angle, side, that angle would have to be between the two congruent sides. And right now it is off to the side, and we do not have a theorem or postulate about that. Any questions so far? Oh, we are going to prove that triangle TUV is congruent to triangle XWV. The first part on any proof is to draw this table. This table is 2 points. If you do not have a table when we're doing these proofs, your problem is technically wrong. We teach you 2-column proofs. You need to make sure you have 2-column proofs. So you start every problem as a proof, just like this. Step 2 is you are going to write your given information. So what is given in this picture? Let's start with the segment. TV is congruent to? So TV has one tick mark, and then VX also has one tick mark. We also have the fact that WV is congruent to which one?
TV.
Is congruent to
Wait, UV.
UV, because they both have 2 tick marks. Are you guys okay with what we did? How did we know these? They were just given. So right off the bat, you list your given information, and you write given, not give, given next to it. Your next step is to now make some sort of statement regarding the triangle. So right now we know 2 sides that are congruent. But we know something else based on these little boxes in my triangle. What do we know about these triangles? Yeah, Cam?
They're right angles.
Yeah, they're right angles. So therefore, we know that the triangles are right triangles. So we can now say that triangle TUB is congruent to triangle XWV. Oh, I said congruent. I apologize, guys. That should be an and sign. I just wrote exactly what was up there. So TUV and triangle XWV are right triangles. And we know that, again, because of the definition of a right triangle.
Wouldn't that mean they congruent? So both between 90 degrees.
So technically our angles are also congruent. That is correct. But for this one we don't necessarily, have to show that part. But in other ones you actually are.
It's too bright. What does number 2 say?
Number 3 says definition of right triangles. So our last, let's go through and see what we have so far. Oh, sadness. Okay. We have our first part. What did we just show in number 3? That they are right triangles. Which theorem has to do with right triangles? Today. Is it side, 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 angle, side, hypotenuse, leg? Which one is it? Hypotenuse, leg has to do with a right triangle. This is what we learned today. So this tells us we are going to try to use hypotenuse, leg. Let's see what else we have that might make that possible. So what is this in my triangle? WV and UV. So WV here and UV here. What are those in my triangle? Is that a hypotenuse or a leg? It's the leg. I'm going to write a little L. TV and XV. What is that in my triangle? It's the hypotenuse. So to use hypotenuse leg, you've got to check off 3 boxes. You have to tell me that it is a right triangle. You have to tell me the hypotenuses are congruent and that the legs are congruent. Once you've done that, we can now make that last statement. We can now say that they are congruent. So triangle TUV is congruent to triangle XWV. And we know this by hypotenuse leg. So each of these are theorems that have like checkpoints, things that you have to be able to show. And right now, we had to show for this one, hypotenuses are congruent, legs are congruent, and then that there's a right triangle. Yes, sir?
So you can't just skip to them being congruent because they're right triangles?
Nope, you got to tell us steps. So first step is we're going to make this chart. So we have statements. And we have reasons. So again, this is the beginning. If it's not in this form, it's not going to be correct. The next step after you do this is to list your givens. This one actually wrote them out. So first given is that RP, or PR, is perpendicular to SQ. And 1 is because that's given. Number 2, we have that PQ is congruent to PS. And again, that's because it is given. So right now we have those 2 pieces of information. Based on the fact that it is perpendicular, what do we know is formed? Perpendicular lines form what? They form right angles, right? So step 3, we're going to show that we have 2 right angles. So, I wrote giant. Let's see if I have enough space. So 3, triangle, or not triangle, angle, PRQ, and angle PRS are right angles. Say it again. It's an and sign. Serenity is correct. Okay, and we know this because of perpendicular lines form right angles. So we're going to write 3 perpendicular lines form right angles. If I write 4 down there, will you guys be able to see it? Okay. So 4. Now that we know that What can we say about those two triangles? If you know there's a right angle in it, what type of triangle does it have to be? It has to be a right triangle. So now that we know it was a right angle, we have to say that we know that they are right triangles. So, see, we have PQR, triangle PQR, and triangle PRS. I wrote those really close. Let's erase that. Oh, is it now too small? Let's try it again. Triangle PQR and triangle PRS are right triangles. And we know this by the definition of a right triangle. Okay, so now if we look at this, this step tells us we have a right triangle. So when we have a right triangle, what are the things that we could be looking for? We can use hypotenuse leg. So there's other ones we could potentially use, but chances are that's a good one for us to try. So right now, you see you have PS is congruent to PQ. What do we know about those two? Where are they in my triangle? PS and PQ, what are they in my triangles? Are they the hypotenuse or the leg? They're the hypotenuse, right? They're what's directly across from that right angle. So we know this is the hypotenuse. So to use hypotenuse leg, we had to show they were right triangles. We did that in step 4. We had to show that the hypotenuses were congruent. We did that in step 2. Now we have to show that there's a leg that is congruent. So right now we have two options. We can show that SR and RQ are congruent, or we can show that PR is congruent to PR. Which one do we have the information to be able to say? So one of these we have something that we are able to say. Do we have any information that tells us the relationship between SR and RQ? But what do we know about PR and PR? So segment PR is congruent to segment PR because of that reflexive property. I'm going to continue mine over here because I don't have room.
Your Apple Watch is picking up everything in this thing. That's something in your shirt. What time do you leave here?
And how did we know those two were congruent? I heard somebody say, yep. This told me that we had a leg. Now that we have that, we have our last statement. What is always our last statement? Our last statement's always what we set out to prove. So triangle PQR is congruent to triangle PRS. And we know this by hypotenuse leg. I'm going to still draw the next one out for you.
That's why I took it.